So last part of 1.6 is, did they take it? Oh. Well, last part of 1.6 is writing an equation with information about transformations. So you're going to be given an original function. So here's an original function. F of x equals x. And then we have a vertical stretch by a factor of 2, followed by a translation 1 unit up. So if there's multiple things happening here, if there's a vertical stretch by a factor of 2, then followed by translation of 1 unit up, this followed by here is going to be like a pause and simplify. Usually followed by means there's an order that it has to go in. So we're going to follow that order. The first thing is going to come first. We're going to pause and see if there's anything to simplify, and then we'll do the second thing. So vertical stretch by a factor of 2. I kind of covered that up a little bit. Vertical stretch by a factor of 2. Let's see, that's going to mean that my f of x is going to be multiplied by 2. So when we have a vertical stretch, it goes on the outside. It's the exact same number when it's vertical. So I do 2 multiplied by the function x, and then I pause and I simplify. What is 2 multiplied by the function x? To xk. So far we have 2x. And then we're going to do the second part. The second part says followed by a translation of 1 unit up. So now I'm going to take this new function and I'm going to add 1. When we do a vertical translation, it goes on the outside. So that plus 1 is going to be outside of the function. So the 2x, and then I add 1 on the outside. In the directions, it does give, it says write a function g. So it's telling us what to call the function there. So I'm going to rename this function g of x equals 2x plus 1. That should have been like way too long to do that problem. I was just explaining everything as I did it, but that is not how long it should take you to do that problem. Some of them do get tricky though, so we have to be careful on some of them. Next one says the function f of x equals x squared. We're going to do a translation 3 units down, followed by a vertical shrink by a factor of 1/3. So the first thing that I'm going to do is a translation 3 units down. So I've got my f of x, and I'm going to minus 3. I'm going to take my function, I'm going to minus 3. So my function is x squared minus 3. Then I'm going to pause and I'm going to simplify. Not really anything to simplify here. And so our new function is x squared minus 3. That's our new function. I'm making this little mark like an apostrophe. Do you guys see this apostrophe that I wrote right here? Does anybody know what that means? Yeah, that's how you say it. It's just meaning like the new one. Instead of writing it that way, I could write just a different letter. So it's not the original f of x. It's not our answer g of x. Maybe it's halfway through, so I'll call it h of x. That's another thing that I could do. So we're halfway done. Now we have to do a vertical shrink by a factor of 1/3. When we do a vertical shrink by a factor of 1/3, we do 1/3 multiplied by the entire function. 1/3 times the entire function. So for our g of x here, we're going to have to do 1/3 multiplied by x squared minus 3. I'm going to simplify that just a little bit, and I'm going to have g of x equals 1/3 x squared minus 1. Can you guys guess where people make mistakes on this? Do you mean like they stop here?
Yeah.
That's not the biggest mistake made. Usually people simplify. Usually they just put the 1/3 in front, but they don't actually multiply it by distributing. Usually the mistake would be 1/3 x squared minus 3. So if that 1/3 is a vertical shrink on the previous function, we have to take the entire function multiplied by 1/3. So we want to try to avoid that mistake. I'm trying my best to show you like how I'm doing 1/3 times the function, but people still do it. All right, next one says f of x equals absolute value of x. We've got a horizontal shrink by, oops, went too far. Horizontal shrink by a factor.
Can you scroll up for a second?
Yeah.
The first one?
The first one.
No,
Did you write something down wrong? So question C is f of x equals absolute value of x, horizontal shrink by a factor of 1/2, I can't talk, 1/2 followed by a translation 4 units to the left. So we're going to do the horizontal shrink first. So if it's horizontal, where does it go? Inside. And if it's inside, we don't use the exact same thing in the words. If it's inside, we use the opposite operation. So if this says a horizontal shrink by a factor of 1/2, what number am I putting inside? It is 2x, 2x. So when we have horizontal, remember we have to do the opposite. The opposite operation. So if I'm doing f of 2x, this means replace x with parenthesis 2x. That's what f of 2x means. So I'm putting it in the function. I'm replacing x with 2x. So my function is absolute value of x. So inside of the absolute value, I put 2x. Now, I used parentheses here because sometimes you really, really need them. So I just do it every time. But in this case, if I have the absolute value parenthesis 2x, do I need the parentheses here? I do not. So I'm going to simplify it. It'll just be absolute value 2x. And that's kind of like my H equation there. That's my halfway done equation. So now we've got followed by a translation 4 units to the left. So if I'm going to the left, it's going to be on the inside. When I do to the left, I'm going to put a +4 because I do opposite. So that's what my next step is, to do h of x plus 4. Wherever I see an x, we're going to replace x with parenthesis x plus 4. So I've got absolute value 2 parenthesis x plus 4. So when I go in this order, I have to put those parentheses in because the 2, when we're graphing, the 2 can't be in the same room, can't be in the same parentheses as the x plus 4. Do you remember when we were graphing that in our notes the past 2 days? Remember we had to factor it out before graphing? Here we're putting it in and it's kind of factored out. Now we will simplify this for our final answer. So I will have g of x equals absolute value 2x plus 8.
I got a question.
Yes.
Why is there an absolute value?
There is an absolute value because right here, it gives you the original function. And so it told me to use absolute value, which was just different. The question before it said here, use quadratic. So it's just different parent function it's telling us to use each time. Okay. For question D, it's telling us to use absolute value. Ooh, look at question D. A translation 4 units to the left, followed by a horizontal shrink by a factor of 1/2. Does that look familiar at all? What, Charlie?
Just that one, but the order's
It's exactly the same as question C, but the order is switched. Do you think we'll have the exact same equation or maybe not?
no.
Let's find out. So we've got a translation 4 units to the left first. So the first thing I'm doing is f of x plus 4. So it's that still same x plus 4. So I'm going to take my absolute value of x and I'm going to replace x with parenthesis x plus 4. So I've got absolute value, parenthesis x plus 4. I don't think I need the parentheses here. If I simplify, those parentheses are not needed. So now we're going to do followed by a horizontal shrink by a factor of 1/2. So my h equation, I'm going to be doing h of 2x for this one. We're going to replace x with parenthesis 2x. So I take my previous equation, absolute value x plus 4, and I replace x with parenthesis 2x plus 4. I'm going to simplify it. G of x equals absolute value 2x plus 4. So does order matter?
Yes.
The parentheses matter. Yes, Ian.
Why isn't it the other way around?
Why isn't what the other way around?
Like, shouldn't it be -4 and then times the 2 with the second one and not the first one?
I'm not sure what you're asking. Are you asking like
Like, don't you have to go in order? So then you go x minus 4 or plus 4, and then you have to multiply by 2 after that.
which question are you talking about, C or D?
So, like, I feel, doesn't it have to
Are you talking about like when we do it in the table? Like when we actually graph it?
No, like, when we get to the function.
So when we get to this step,
Yeah.
okay, now what are you saying again? When we get here,
It feel like it looks like it should be the other way around.
it looks like I should have these two switched.
Yeah.
Right.
But I can understand.
Can we look at them graphed? Let's look at them graphed, okay? It's the followed by that makes it matter. So there's our parent function, absolute value of x. Let's see if I can make it dashed. There we go. All right, so one of them was absolute value 2x plus 8, right? The other one was absolute value 2x plus 4. I think I actually need to put in just 2x first. Now there's way too much going on that it looks confusing, right? Okay, so with, you know what, I think I know how to explain this. With the first one, we shrank it first, right? Like we made it skinnier first. That was the very first thing that we did. So with the first one, here's our red absolute value. Then I made the black absolute value 2x. From there, this has to move 4 to the left. And so when I turn on 2x plus 8, do you see where it hits at 4? Okay. And that's because when we actually go and graph it, and we make our table that we did yesterday, we would be using this guy to make our table. And there's that -4 that we would have in the table. Okay. Now, if I do it in the other order, this is the one that's more challenging for me to show you, but I'm going to show you. If I do it in the other order, so I don't need that guy anymore. Don't need this guy anymore. If I do just the +4 first. So if I just do +4, we've moved it. Now what we're going to do is we are going to shrink it horizontally. But when we shrink it horizontally, it's going to actually get closer to the y-axis. And this is already pushed off the y-axis. So it's not like both sides are going to come in. It's like the left side is going to come in more. So shrinking it horizontally just gets it closer to the y-axis. So now when I do absolute value 2x plus 4, it's like going from the group. Ooh, I'm going to do it this way. Hold on. Just make this like a variable. That way I can do it slowly. So when I take this absolute value something x plus 4, as I'm getting closer to 2x, do you see how this guy is getting closer and closer and closer and closer to the x and y-axis? Do you understand that? So when we do a horizontal shrink, it pushes it closer to the x-axis. Now, if it's already on the x-axis when we do a horizontal shrink, it looks like just both sides come in. And that would be something that is definitely confusing to understand unless you can see it here. Do you guys see it? What's happening here? So again, it was moved over 4. And then when I shrink it horizontally, the green one just gets closer to the x-axis. It does get skinnier, but it's a little bit different than that previous example. So that's why order is going to matter when we do this. Order matters. All right, we have one last one. F of x equals 1 over x. We're going to do a vertical stretch by a factor of 5 and a reflection in the x-axis, followed by a translation 3 units right and 4 units down. So vertical stretch by a factor of 5 and a reflection in the x-axis. If it's a reflection in the x-axis, is that vertical or horizontal? Vertical. In the x-axis is vertical. So both of these are vertical. So we take a negative and a 5 and we multiply it by our function. Our function is 1 over x. So negative 5 multiplied by 1 over x. So I'm going to simplify that and I'm going to get negative 5 over x. Why is it not negative 5 over negative 5x? Why didn't I put a negative 5 here also? Are you talking, Colin? Because the negative 5, yes. Because this negative 5 right here, this negative 5 right here is over 1, and we multiply straight across. Thank you. And then after that, we have to do followed by a translation of 3 units right and 4 units down. So from my h of x, I'm going to have 3 units right, which is x minus 3, and then 4 units down, so minus 4 on the outside. And the h of x equation we're going to use is this one right here. So if I do x minus 3, that means replace x with x minus 3. So my equation is going to start with -5 over x minus 3. And then the minus 4 goes on the outside of that function, minus 4. And then I don't really need those parentheses in the denominator, so I could erase them. Oops, I just wrote them again. I could erase them or just rewrite it. You guys could erase it. I'm rewriting so that you can see both of my steps. Do you see how quickly I was able to graph it on Desmos on those last two examples? I was able to quickly graph it. Please use Desmos when you're learning. So it doesn't take you very long to kind of check to make sure you're doing it right. Make sure your graph matches what this says. Okay, that's it, right? Yeah, that's it for notes. You guys can finish that other worksheet that you couldn't finish yesterday. You have the rest of the time to work on stuff. I'm going to start calling you all up for conferences for the quiz.